Hello and welcome back to Maths in Chemistry questions for you to practice. This is test number 5 out of a series of 10 sets of maths questions for you to have a look at. So the first one then, this is for everybody, whether you're on foundation or on higher. This is a straightforward 1 mark question. So the Haber process is used to make ammonia from nitrogen and hydrogen, just so that you know it is actually a reversible reaction as well. The nitrogen that is required for the Haber process is obtained from the air, which is 78% nitrogen. How many centimetres cubed of nitrogen are there in 24 centimetres cubed of air? So all I've done is I've converted the 78% by dividing it by 100, and then 24 times 0.78 is 18.72, or if you're rounding it up, it's 19. Straightforward 1 mark question. Okay, question 2. Now this one again is for everybody, a little bit more difficult. It's 2 marks for this one. So copper oxide was reacted with sulfuric acid. So this is one of the required practicals in paper 1 for chemistry. The reaction produced 32.2 grams of copper sulfate. So straight away I'm thinking, right, they've given me some grams here. They've actually given me some mass. The percentage yield for this reaction was 78.6%, so that's how much I actually made. Percentage yield just means how much you actually make out of something. Using the formula below, calculate the maximum theoretical mass of copper sulfate that could have been produced in this reaction. Again, I've put this into a triangle, and I need to work out the maximum theoretical mass of copper sulfate. So I want this one at the bottom. I want this one. So I've put this one above the divide line over here. So the mass of the actual, the percentage yield, and that. So I'll pick out the calculation I want, the mass of the actual, what I've actually made, divided by the percentage yield. And I've just written that down. That is my calculation. Then I just put my numbers in. I take my 32.2 grams out of my question, because that is my actual mass, how much I made. I'll put my percentage yield of how much I made as a percentage, I'll put that there. That divided by that times 100 equals 40.966. But if they ask you to convert it to 3 significant figures, it would just be 41. Okay, because of the 966. Right, so question 3. This question again is for everybody. A reaction is carried out. The mean rate of this reaction over the first 120 seconds is 0.140 grams per second. Use the formula below to calculate the amount of product that would form after 120 seconds. So this time I'm putting it again into a triangle. There's a divide line. Amount of product goes at the top, rate and time at the bottom. I need to work out how much product I would make. And I know that my rate is 0.14, because I've been given that, times the amount of time that I want, and the answer is 16.8 grams. Right, question 4. This one is just for higher students only. So, a student neutralised a solution of sodium hydroxide with hydrochloric acid. So really, all I'm looking at here is an acid-alkali reaction. The concentration of the sodium hydroxide solution was 0.500 moles per decimetre cubed. Okay, so I haven't got to do anything there because decimetres cubed is okay. The number of moles of sodium hydroxide used was 0.0175. Okay, so it's given me the concentration and it's given me the moles. Use the formula to calculate the volume of sodium hydroxide solution, but give your answer in centimetres cubed. And it's giving me the conversion there. So I'm like, okay, I'm going to need to do something with that in a minute. But I'm going to do it stage by stage because this is a 3 mark question. So first of all, I've got to work out which calculation I'm going to use. They give me this, again, put it into a triangle. There's my divide line. There's my divide line. Number of moles will go at the top. Concentration and volume will go at the bottom. I need to work out the volume. So to work out the volume, I'll put my finger over volume and it tells me it's number of moles divided by concentration. Well, my number of moles is here, was 0.0175. My concentration was there, 0.500, equals 0.035 decimetres cubed. That would get me 2 of the 3 marks. But it's asking me to convert it into centimetres. So I take that and I multiply it by 1,000 and I get 35 centimetres. And that'll get my 3rd mark. Okay, back to question 5 for everybody to have a go at. A scientist tested the boiling points of different hydrocarbons. A histogram of their boiling points is shown below. How many of the hydrocarbons tested had a boiling point between 10 and 90 degrees? Okay, so the first thing is, I only need to be working with these 2 blocks here because it's just asking between 10 and 90 degrees. But I have to take into account how wide these blocks are. Now this is 40, representing 40, and that's representing 40. So all I do is all I've done here, and please, whenever you're using graphs and taking data, use a ruler to make sure you're really precise. I've just put some lines there to say, right, I'm just working on these. Don't be afraid to write on your graph so that you know what you're dealing with. So I need to work out, first of all, the 10 to 50. So if I use my ruler to go across and I draw a line and I'd say, okay, if I now count up the blocks, I can work out that that's 0.125, but it represents 40, so that times that equals 5. And then if I do the same again for the second one, go across, the answer is 0.05 times 40, again, because that's how wide the block is, equals 2. 5 add 2 equals 7. Okay, so because it says how many of the hydrocarbons tested, the chances are it was always going to be a whole number, and in this case it is. And I look forward to seeing you on test number 6.